I'm physics graduate student in the University of Texas Arlington, and today I'll be presenting confidence limits on the mass of supersymmetric particles at the high luminosity LHC conditions. So I'll begin with the standard model. So it explains the world around us in terms of particles and fields. So it is a successful theory in particle physics, but it is unable to explain some things like the current value of the mass of Higgs, which is a light, and Standard model predicts it to be hues. And the Standard model is also unable to explain what is dark matter. So we have a new theory of supersymmetry which introduces new particles, which are spin half difference mapping of standard model particles. So if standard model particle is a fermion, the corresponding supersymmetric particle will be a boson. And similarly, if the standard model particle is a boson, the new supersymmetric particle will be a fermion, and so on. So this theory brings down the mass of Higgs because the Higgs receive equal contributions from standard model particles and the supersymmetric particle. And this theory has dark matter candidate, which we call as the lightest supersymmetric particle, and also that is the same as neutrino. And in our searches, we look in at the proton-proton collisions at LHC, where the stop quark is produced in pair, and it decays to a final state of two leptons, a bottom quark, and neutralino. And we define two signal regions, SRT and SRW, where the difference of mass of stop and neutralino is equal to the mass of top and W respectively. So after the increase in LHC's energy and new improved integrated luminosity, there should be more signal in background, which is shown on this table. So here on this table, you can see that the signal in different channels is increased at the high luminosity conditions. And to obtain the results, the top two plots shown here, the exclusion plots, we use CLS methods. So it is used to set upper limits in new physics searches. So at 95% confidence limit, if the CLS values shown in the top two plots are less than 0.05, we exclude the signal model at that point. So here you can see on the top two plots, the left plot is the exclusion plot using RON2 conditions, and the right two is exclusion plot at high luminosity LHC using RON2 cuts. And on the bottom four plots are the n-1 plots, which are used to postulate the new cut, and the black arrow shows the old cut. So we have to get a new cut where signal is more than background in these four plots. Um, so after we get those new cuts, we'll apply those new cuts in the high luminosity LHA conditions to get the new exclusion limits, and that will set new exclusion limits for the stop in neutralino, or we might be able to discover them at the high luminosity LHC.